Hey, hey. Today I'll be talking about Stylus and Stylus EVM, and smart contracts. I think I'll touch in brief what Stylus is. It's the way to run smart contracts that have a target for WebAssembly. On any WebAssembly compatible language, you can write smart contract that will be able to call any Solidity contract. So it has full interoperability. Um, and let's start with major changes that happened in the ecosystem for the whole year of development. I'll touch here differences of Stylus and Solidity. As you see, the major difference is constructors. So it's very different to construct contract on Stylus. Inheritance is different. Because the main language for Stylus EVM is Rust, because it has it actually works quite well with WebAssembly. The other things that are quite different, but not much, are context functions. If you wanted to make external calls, it's also kind of similar but different. And I also touch some interesting quirks. Yeah, let's get started. It actually how it was before. If you wanted to instantiate your contract, you had a few ways. First, parameterize your contract with generics. So it's common approach in Rust, but it actually the argument will be determined in compile time. And sometimes you want to do some logic when you instantiate your contract. And the other solution was to use functions initializers. As it was before, so it wasn't any constructor special function, and OpenZeppelin created a solution that was called COBA, where it was possible to write constructors on Solidity. So it actually was pure disaster because code base of Solidity and Rust been coexisting. And it kind of ruins whole point of using Rust for smart contracts. If you remember, the first question of the presentation is, are we on EVM? So it kind of really no with that kind of approach. And I'm happy that we deprecated it. And these changes happened quite recently, so that is how constructors works at the moment. You just need to decorate constructor with a constructor macro, and it actually not a major difference from Solidity. This change was introduced by Off-Chain Labs quite recently, and that is how it works. And here you can write like any kind of logic. So it's example of ERC71 token with consecutive extension. So let's go forward. So inheritance. In Rust, there is no inheritance. It's mostly term from object-oriented programming languages, but Rust, it's not like that. So it's like all inheritance is decomposed in Rust. There are generics, there are traits, but yeah, there is no virtual functions. You cannot override functions. At Stylus, to address this issue, they added inherit keyword. So you just write inherit, and all functions from inheriting contract are re-exported. And the problem was that it wasn't working on level of 3, so it was quite useless. This is example, and it's shown like where it compiler won't let it to be compiled. Of course, trying to solve this solution, developers could start creating some different approaches, and here it's where it will be totally wrong. This example will be compiled, but as you see, the third level contract is duplicated, so it's like just think that you have like 2 tokens inside one contract, and you changed balance in one, and in the other you just read, and update wasn't perceived. That was totally wrong approach, and that is how it was before. And the only solution was just use inherit keyword on client side, so only developers will use it. So it was useless on library side because level of 3 was not supported. And how it is implemented now, so they added implement keyword. And actually there is no like inheritance concept at all. You just implement some trait, And you should link it to your contract. So, and you can add some functions like constructor, like function for minting in case of NFT token. So, but yeah, consumer is responsible for publishing API, and that is what they should do. So just decorate with public and implement all those traits for ERC-701, or if they want to add some extension, implement it for burnable. So this is more verbose, but actually more clear for developers. So with errors, kind of no major changes. You can use just a set of bytes as a errors, a vector of bytes, or you can create typed errors. That is more preferable. But if you just want to set up your contract quickly, so just use the first option. Yeah. Context function, like for this year, changed, but not much. Stylus SDK team added VM API, and where you can conveniently choose what function you need, like you want to read contract address or message value that was sent with transaction. So it got more convenient, but the previous API is still available, but will be deprecated soon. External call also has no major changes, so that is how it looks. You can use also VM API for it, but yeah, by the end you should just write some Solidity contract, and then that macros generate the function, and you just call it. And then we come to the interesting quirk that wasn't addressed at all. So it's actually the difference of Rust and Solidity, that in Solidity function name, so like it can exist two functions with the same name but different set of arguments. In Rust, it's impossible. And since we are building compatible contracts, compatible with Solidity, so we should assume that we could have like some functions with the same name. And that is the only solution. And the bad thing that nowadays user who publishing the interface should also remember that that name should be different, so like write it each time. So I think that problem will be fixed in future, and I hope so. Yeah, here I'll touch a few topics about library development. So actually, like it was before, it's preferable to design your error types for your contract, and yeah, and have they rely more on type system that Rust provide you. So for inheritance, trade-based approach is preferable. So library should have some set of traits that it's expected from user that they export it, and also some core logic implementation. So just for example, ERC-20 trait and burnable extension. So that is what we expect from user to publish, and what user should do, just implement them and forward to exact type from library. And the last thing that actually necessary for libraries is just to validate that code works correctly. So it's end-to-end testing. And testing overall, so no major changes here. You can use like whether Ethers RS or Alloy provider and write your test cases. That is example how it can look like in our library. And of course, there are some drawbacks for end-to-end testing. So for example, they cannot pass fast. So and of course, like unit tests are much more preferable. And if you want to run the same test case multiple times with randomly generated arguments, to like hoping to find some mistake, yeah, like prop testing or fuzzing also is not possible. And for end-to-end test, you have infrastructural dependencies. So you should first deploy Nitro test node and wait for it. So, but yeah. The downside of unit testing that it's not compatible with Solidity, so you only can check interoperability in end-to-end testing. So, but yeah, here is the example of how slow can be end-to-end test. So like we have 300 test cases, or I think a bit more, and it already takes 21 minutes to pass. So maybe if we will cache cargo stylus, it will be like 3 minutes faster. But anyway, it's like it's scaling in a disastrous way. So yeah. And the thing that appeared, so Off-Chain Labs, developer of Stylus SDK, they also created test framework, so they call it Stylus test. It's more imperative, so you should write what should you mock, so which functions should you mock. So of course it can run in parallel. It's just recent solution that recently appeared. So, but at least one test framework exists, and the other is developed by OpenZeppelin Mozzo. So also my colleague Nenet published article recently. So like cool guide about Mozzo. So yeah, it also runs in parallel, but compared to Stylus test, you can write test cases in more declarative way. For example, let's skip it. So here is example of positive and negative test case. So and yeah, it looks quite simple. So it's quite understandable what you're doing. So like, who is the sender, and you don't need to hard code any addresses, because addresses are derived from names of arguments. So for example, Alice address derived from Alice string, and for Bob it's same. Also, you can check for events, you can check for errors. So if, for example, if this contract returned with error, it actually storage will be reverted. So it's like kind of like a micro EVM implementation beneath. But yeah, it actually works. Also, in case of testing two contracts, so you don't need to mock, you can just create another contract. Like there is ERC71, and ERC71 has a receiver extension, and you can just create a receiver contract, and when you send NFT to receiver, it will that API will be triggered. So, and you can check that it worked. So actually, you can use like as many contracts as you need. So it works quite similar to what exists on real on-chain environment. So, and the last point, like last advantage of Stylus, why Stylus actually was created, is that it can show some benefits in terms of performance. So like actually, it was advertised that it can be cheap. So, and here are example of benchmarks. So we actually run benchmarks after each pull request get merged. So it's actually very simple to understand like what happened wrong, or like which changes introduced increased gas cost. So you see that there is a column to that cached contract. So it's possible on Stylus to cache contract, and to call will be a bit cheaper because you don't need to load WebAssembly, so like and spend gas on it. So, and also you can play with WebAssembly with external tools, so and optimize it and make it better. And the worst thing about it that it's actually worse than Solidity. So all of those results, it's not 21,000 gas fee is not considered here, so you should append it if you want to like note the price of the call in total. So yeah, it's all of it is a bit worse than Solidity. That's a bad thing. And the same thing for ERC71. So mostly it's a bit worse. Sometimes it's same, sometimes it's worse. So in the most optimized way. And that is the thing about Stylus, that for simple scenarios, for simple tokens, it is not that optimal to use. But of course, if you don't have a target to optimize tokens, you can use it for the other applications. For example, we built Poseidon hash that is currently a bit Solidity quite well. So, and that is the area where Stylus shines. So like when you build some computationally intensive smart contracts, when you want to pull something like some game on chain, like I also heard like something been trying to pull AI model, or yeah, like just write some crypto primitives, and the result can be result will can surprise you. So, and the best thing that in this article I also described, not just the result or numbers, because better not to trust numbers. For example, it's after recent updates, it got a bit worse, and yeah, like we won't go like to change title of article, so like from like 18 times more to like 17.5, yeah, and but the good thing is that the idea, the optimization steps, how you can improve your performance of your smart contract are actually quite similar to what you're doing to optimize like your software on your like normal computers. So loop and rolls, inlining functions, so like all of that can bring you results. And it's similar to modern CPUs. Division operation is more expensive than multiplication. So in Solidity, those subcodes charges same. So yeah, that is actually the thing where it makes sense to use Stylus. So thank you.
All right, we're going to open it up for questions here. We have about 10 minutes for questions. So if you just have a question, just raise your hand.
You mentioned that Stylus shines for use cases that are not the common ones, and you mentioned the Poseidon hash implementation. What other primitives, cryptographic or not, are in the pipeline, so that can be applied to other use cases?
It's actually hard to tell. Yeah, like we're thinking about our roadmap. But yeah, there are like different projects like Renegade Labs. They're building MPC on chain. So so like superposition. So it actually, yeah. The most obvious, yeah, it's some you know, like cryptography, like ZK friendly hash, like Poseidon or Pedersen hash. So the other things, yeah, like I don't know, like you want to play some like on-chain game, that also can work. So, but yeah, we haven't tried, and it's actually hard to build roadmap over it, especially knowing that we should build some library that people will use, like how people would use like some game, like I don't know, like, but yeah, tokens are not the best part of Stylus.
All right, thank you
Okay.
so much. If there's no more questions, I appreciate it.